مطالعه مدلسازی نشان می‌دهد مناطق قطبی ماه ممکن است میزبان میکروب باشند. یک مطالعه جدید نشان داده که مناطق همیشه در سایه ماه، یعنی دهانه‌های قطبی که نور خورشید نمی‌بینند، ممکن است بتوانند میکروب‌ها را برای مدت طولانی حفظ کنند. این مناطق به دلیل سرمای شدید و نبود پرتوهای فرابنفش، محیطی محافظت شده برای میکروب‌ها ایجاد کرده‌اند، هرچند این میکروب‌ها نمی‌توانند آنجا رشد کنند. محققان با مدلسازی 2 دهانه شاکلتون و فاوستینی که از اهداف مأموریت‌های آرتمیس ناسا هستند، به این نتیجه رسیدند که شرایط خاص این مناطق می‌تواند میکروب‌های زمینی را زنده نگه دارد. این یافته‌ها به درک بهتر مکان‌های احتمالی حیات در منظومه شمسی کمک می‌کند. انگیزه این پژوهش از بررسی آلودگی میکروبی فضاپیماها شروع شد و با پیشرفت مدل‌های نورپردازی، محققان توانستند احتمال بقای میکروب‌ها را دقیق‌تر بررسی کنند. این موضوع به ویژه برای اکتشافات انسانی مهم است، چون انسان‌ها می‌توانند میکروب‌های بیشتری به ماه ببرند. این مطالعه هشدار می‌دهد که آلودگی میکروبی ممکن است تحلیل‌های علمی آینده مثل بررسی یخ آب در این دهانه‌ها را تحت تأثیر قرار دهد. احتیاط در اکتشاف این مناطق می‌تواند به حفظ شرایط طبیعی آنها برای تحقیقات کمک کند.
In order for NASA to map and explore the region around the lunar South Pole, we need to precisely define a system of latitude and longitude on the Moon, including the exact location of the South Pole itself. In the coordinate system adopted by the Lunar Reconnaissance Orbiter mission, the South Pole is here, on the rugged rim of Shackleton Crater. If you stood on this treacherous spot, you'd see the sunlit rim of the crater encircling a permanently shadowed abyss that's 2.5 miles deep, over twice that of the Grand Canyon, covering an area over 130 square miles. As we return to the lunar surface, three-dimensional maps like this will help guide astronauts to safe landing sites in the challenging landscape of the Moon's South Pole.
Outer space is not friendly to life. Extreme temperatures, low pressure, and radiation can quickly degrade cell membranes and destroy DNA. Any life forms that somehow find themselves in the void soon die, unless they band together. As small communities, new research shows some bacteria can withstand that harsh environment. Today we will discuss about how space microbes survive in space. Welcome back. This is Signature's Life. Space microbes, otherwise microbial astronauts, are the microbes that are found living in space. Scientists studied how they are capable of living in space. Balls of Deinococcus bacteria as thin as 5 sheets of paper were placed on the outside of the International Space Station, stayed there for 3 years. Microbes in the heart of those balls survived. The group's outer layers had shielded them from the extremes of space. Such microbial groups might be able to drift among planets. This could spread life through the universe. This is a concept known as panspermia. It was known that microbes could survive inside artificial meteorites, but this is the first evidence microbes can survive this long unprotected. It suggests life can survive on its own in space as a group. Astrobiologists sent dried pellets of Deinococcus bacteria to space in 2015. These radiation-resistant microbes thrive in extreme places, such as Earth's stratosphere. The bacteria were stuffed into small wells and metal plates. NASA astronauts affixed those plates to the exterior of the space station. Samples were then sent back to Earth each year. Back home, researchers moistened the pellets. They also fed the bacteria food. Then they waited. After 3 years in space, bacteria in 100 micrometer thick pellets don't make it. DNA studies suggested that radiation had fried their genetic material. The outer layers of pellets that were 500 to 1000 micrometers, otherwise 0.02 to 0.04 inch thick, also were dead. They were discolored by ultraviolet radiation and desiccation, but those dead cells shielded inner microbes from the hazards of space. About 4 in every 100 of the microbes in those larger pellets survived. Scientists say that 1000 micrometer pellets could survive 8 years floating through space, and that's enough time to potentially get to Mars. Rare meteors might even be able to travel between Mars and Earth in a few months or years. How exactly clumps of microbes might get expelled into space is not clear. The microbes might get kicked up by small meteorites, or they will be might thrown from Earth into space by thunderstorm-induced perturbations to Earth's magnetic field. Someday, if microbial life is ever discovered on Mars, scientists hope to look for evidence of such a journey. That will be the ultimate dream.